So here's another example. You won't find this one in the book, but it's fairly straightforward. I would want to calculate, and this is going to be very similar to a factorial. What this function is going to do, this method, is that we are going to add up the numbers 1 through n. So 1 plus 2 plus 3 dot 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 plus 4 plus plus m minus 1 plus n, all the way up to n, right? And we're going to do it recursively, right? Because we see this, pattern a lot. So let's think about our base case here. If n is equal to 0, and you should try this after you do after I give you the base case. If the n is equal to 0, and I'll go ahead and say less than or equal to 0, return 0, right? Otherwise, what are we going to do? What is the recursive case here? So I want you to take a moment and figure out what the recursive case is, right? Summation is going to, so if I do 5, right, that's going to add up all the numbers 5. If n is 5, that's going to add 5 plus 4 plus 3 plus 2 plus 1, right? That's what I'm saying, and so we're going to return the sum of 5 plus 4 plus 3 plus 2 plus 1, as opposed to factorial where we're multiplying everything together, right? So with that in mind, what is the recursive call going to be? So you should, stop yourself here and figure that one out before moving on. So 5 plus 4 plus 3 plus 2 plus 1, we realize, well, that's the same thing as 5 plus the summation of 4. So what we want to do is that we want to return 5 plus, well, not 5, but n plus the summation of n minus 1. And 15, which should be our answer, 5 plus 4 plus 3 plus 2 plus 1. So that should be, 9, 12, 14, 15. So it sounds like it's correct.